Hello dear students, welcome back to physics online class. So I hope in last class you are getting information about that cell, so terminal potential difference, internal resistance and as well as external resistance. So related to those things, so we got that mathematical expression here, so that is, so relation between current, EMF, external resistance and internal resistance. So I is equal to E divided by R plus of R we can consider, and relation between terminal potential difference and EMF, V is equal to E minus of I into R, and one more equation. So for that internal resistance we can say, so E minus of V divided by V into R here. So where small r represents that internal resistance of a cell, or I can rewrite that E by V minus of 1 into R. So these are all the equations related to current, EMF, external resistance and internal resistance, terminal potential difference and EMF, and internal resistance equation. So now in today's session, so we will be focusing on different concepts in case of cell here. So for example, in case of cell we can consider that charging cell, discharging cell also we can consider. What's the mean of that charging cell and what you mean by the discharging cell, we will look at now. So we will look at about different concepts of cells. So in that one, so we'll understand that what is the discharging cell and what you mean by that charging cell, we can understand here. So first we'll take that discharging cell. So first we'll make you understand about that discharging cell. So what's the mean of the discharging cell here? For example, cell consists of two terminal, one is positive, another one is negative here. Positive I can take it as anode and negative I can take it as cathode here. So look at here, in case of the discharging cell, current is flow from that cell to the circuit. So look at here, current is flowing from that cell to the circuit. So this is the cell, so current will flow from that cell to the circuit here. So for example, whatever the bulb you can consider, a resistance element, whatever the elements you can consider, in case of the discharging cell, current is flow from that cell to circuit. So in case of discharging cell, what is the first thing I need to understand here? Current is flowing from, so current is flowing from cell to circuit. So means that is about discharging cell. So current is flowing from cell to the circuit is nothing but discharging cell. In case of the discharging cell, within the cell, current is flowing from that cathode to anode. So remember point, inside this cell, current is flowing. So what is the direction here? Inside the cell, current is flowing from cathode to anode. So inside the cell, current is flowing from that cathode to anode here. So what about outside the cell? So outside the cell means, so for example, take one resistance here. So what about that current in case of outside the cell here? Outside the cell is from anode to cathode. So look at here, I can take outside the cell is, so that is anode to cathode. So anode to cathode outside the cell, inside the cell means cathode to anode here. What is that mathematical expression for that terminal potential difference and EMF in case of discharging cell? So that is V is equal to E minus of I into R. So this is about discharging cell. So remember one thing, in case of the discharging cell, EMF of the discharging cell is always greater than the terminal potential difference. So I said about that EMF. So EMF means, so potential difference across the end of the terminals of the cell when circuit is open, or open circuit cell we can call. For example, if you are purchasing cell from the shop, so that is EMF here. So that EMF value is greater than the terminal potential difference in case of discharging cell here. Now we'll look at what about for charging cell here. So now we'll discuss about charging cell. So discharging cell means, for example, in remote control or in wall clock you are using that cell. So that cell is So discharging cell. What about the charging cell here? So for example, in case of the charging cell, I can take one is positive, another one is negative terminal, positive and negative. Positive is anode, negative is cathode here. In case of that charging cell, current is flow from that circuit to the cell here. So remember one thing, in case of that charging cell, current is flow from that circuit to the cell. For example, in case of the mobile, battery is present, right? So in order to charge that mobile, so you are going to be plug in for that board here, so that current is flowing from that board to the mobile here. So did you get my point? Current is flowing from circuit to the cell here. So circuit to the cell, current is flowing inside the cell here. Here current is flowing outside the cell. Current is flowing outside the cell means, so that is about discharging cell. Current is flowing towards the cell means, so that is about charging cell. So for example, in case of mobile battery, so you are going to charge that one. So current is flowing from that circuit to the cell here. So that kind of cell you can consider as charging cell. So remember one thing, in case of charging cell, current is flowing circuit to the cell, here. So in case of that charging cell, so we can consider that inside the cell, so in case of discharging cell, inside the cell current is flowing from cathode to anode. But in case of that charging cell, inside the cell, inside the charging cell, inside the cell, current is flowing from anode to cathode. So remember one point. So in case of the charging cell, current is flowing means inside the cell current is flowing from that anode to cathode. While in case of discharging cell, so inside the cell current is flowing from cathode to anode. For charging cell, anode to cathode here. So now we can consider in case of the charging cell, so what's the value of EMF here? So EMF value in case of charging cell is always less than that of terminal potential difference. So remember one point here, equation for that charging cell. So V is equal to E plus of I into R. Remember here I written as V is equal to E minus of I into R. So why? Because so terminal potential difference value is always less than that of EMF in case of discharging cell, but whereas in case of the charging cell, terminal potential difference value is greater means, so E plus of I into R. So in case of that charging cell, terminal potential difference value will be greater than the EMF of the cell. We can take it here. So hope you understand about the discharging cell and charging cell here. So remember one thing, discharging cell means current is flowing from that cell to the circuit, means current is outside the cell for discharging. For charging means, so current is flowing from that circuit to the cell, means current is flowing inside the cell. You can remember here. So this is the connecting formula here for discharging cell and this is for charging cell. So now we'll look at that. What is that open circuit cell and what's that closed circuit here, or short circuit you can consider. So hope you understand about that discharging cell and as well as charging cell. Now we will understand that one more terminology, so that is open circuit and another one short circuit. So what's that open circuit and what is that short circuit, you can understand now. So look at here. Next we will be focusing on third point, so that is open circuit. So open circuit means if the cell is connected to infinite resistance. So for example, that cell is connected to external resistance, so that external resistance value is infinite. So suppose this is one cell I can take, okay. So this is the resistance, external resistance, its R value is infinite. So look at here. So in case of that open circuit, so cell is connected to infinite resistance. infinite resistance. So if that resistance is infinite, means is that current will get flow here? So current will not get flow in case of infinite resistance. So current is not flowing, means I can rewrite this equation. V is equal to E minus of I into R. Current is not there. So E is equal to what? V here. So for example, if you connect that cell to the infinite circuit, then what happens to that terminal potential difference? Terminal potential difference is equal to EMF of the cell for open circuit. So one more thing I need to understand, so that is short circuit. So what's that mean of that short circuit? So in case of that short circuit, for example, cell is connected to that of a conducting wire. So that conducting wire having that zero resistance, means that conducting wire not opposes for the flow of current. So that kind of circuit I can call it as short circuit here. So again, let me consider one battery here. So this is one conducting wire here. So this conducting wire does not make any kind of opposition, means entire amount of current will get flow here. So look at here, in case of short circuit, so cell is connected to a conductor, its resistance value is 0. So what about that short circuit here? Cell is connected to conductor, so whose resistance value is 0. So R value is 0. So what it means here? Its resistance value is 0 means, so whatever that energy is there, so that energy will get flow from that one point to another point in a short interval of time. So entire amount of energy will flow from that one point to another point in a short interval of time, means so there is no potential difference concept. So in case of short circuit, potential difference value is 0. Within a fraction of second, entire energy will drop from that one point to another point. So if that terminal potential difference is 0, means I can take that I into R is equal to E, where I is equal to what? E by R I can consider. So that is about a short circuit. In case of that short circuit, that cell is connected to the conductor whose resistance value is 0. So if that resistance of the conductor is 0, means entire amount of energy immediately will come from that one point to another point. So there may not be a potential difference here. So look at here, so if that potential difference value is 0, means I can take that I is equal to E divided by R here. So now let me understand that one more term. In case of that cell, for example, current is flowing from that cell to the circuit, right? So now I have to consider how much percentage of the total energy is used in driving the current here. So current is driven from that cell to the circuit here. So now I have to find out that mathematical expression for that. So 1 minute. So I have to find out that mathematical expression for percentage of total energy. So I can consider that energy in terms of percentage. Percentage of total energy used. So how much percentage of the energy I am using from the cell I can consider. Percentage of the total energy used in driving the current from the cell. So from the cell current is flowing here. How much percentage of energy I am utilizing, or in other sense I can find out that efficiency of the cell. By simple name I can take efficiency of the cell. Which thing I need to find out here? I want to find out that efficiency of the cell here. So in order to find out that efficiency of the cell or total energy used in driving the current here, so from the cell I'm going to be drawn certain amount of current here. How much energy I am going to utilizing from the cell I want to determine. So in order to determine such thing, I can take that terminal potential difference divided by EMF here. So V is equal to what? From Ohm's law, I into R. So I is equal to E divided by R plus of R, or E is equal to, shall I write this equation as I into R plus of R, I into R plus of R. So I term will getting cancel out here. So look at here, V by E is equal to what? R divided by R plus of R. In terms of percentage I can say, so look at here, in terms of percentage, so energy driven in terms of percentage is, so R divided by R plus of R into 100 I can take. So this is the percentage of total energy used in driving the current from the cell, or in case of that efficiency of the cell I can consider. So what about in terms of internal energy here? So I can consider that second point here. So this is about efficiency of the cell in terms of internal energy, in terms of internal energy, how much energy is getting lost due to the cell I can find out. So in terms of internal energy means, so I can take that same thing, V by E, here I into R, so small r represents that internal resistance of a cell, I into R plus of R. So in terms of percentage, R into 100 divided by R plus of R. So this is energy loss in case of that cell in terms of internal energy I can consider. So this is about efficiency of the cell here. So hope you understand these things. So in last video, so we are discussing about the terminal potential difference and EMF of the cell, right? Now I have to consider what are the difference between these two terms, what are the difference between EMF and terminal potential difference I need to understand. So hope you understand about that cell, EMF, terminal potential difference, internal resistance of a cell, and relation between current, EMF, external resistance and internal resistance, relation between terminal potential difference and EMF of the cell, and equation for internal energy also. So now we will be focusing on what are the difference between EMF and terminal potential difference. Most of the time in theory examination they may ask these kind of questions. So write the difference between EMF and terminal potential difference. So let me discuss about those sub concept here. So difference between EMF and terminal potential difference here. So what's the first difference? So first you may write the definition. So what is that EMF here? So I don't want to write it here. So EMF means potential difference across the terminals of the cell when circuit is open here. So EMF means open circuit. So whereas terminal potential difference means potential difference across the terminals of the cell when circuit is closed, I can say that. So that is the first difference by the definition I can say. So in case of that EMF value is always greater than the terminal potential difference. So look at here, EMF value is always greater than the terminal potential difference in case of discharging of cell. So whereas the terminal potential difference value is always less than that of EMF of the cell. So that is the second difference. Now we can consider EMF is independent on the external resistance. So look at here, what is the third point I need to remember here? EMF is independent on external resistance, means EMF means you are not going to use that cell. So if you are not going to ready to use that cell means, so that EMF is independent on the external resistance value. So it is independent on external resistance. So whereas terminal potential difference is depends on external resistance. And here one more thing I need to consider about that EMF. So those are important points. So EMF, it measures that energy source. So it measures energy source. So if you find that EMF of that any cell means, what's the physical meaning of that value here? So the physical meaning of that EMF value is it measures that energy source. Then what about the terminal potential difference? It measures the potential difference between 2 points. So it measures potential difference between 2 points here. And so another one more difference is there. EMF is cause, so it is a cause, and terminal potential difference is a effect. So what's that mean of that cause and effect here? So EMF is a cause, means it is the reason for the flow of current. So EMF is act as a cause here, whereas terminal potential difference is a effect. Effect means total outcome, we can say. So look at here, EMF is act as a cause here, whereas terminal potential difference is act as a effect. So EMF is act as a cause, means it is act as a reason here, whereas terminal potential differences act as a effect, means so it is the total outcome we can consider. So that is about terminal potential difference. So these are all the difference between EMF and terminal potential difference here. Okay, so now we'll look at that numericals related to those concepts, whatever the discussion is going on. So we'll solve some numericals related to those things. A battery of EMF 10 volt and internal resistance 3 ohm. So one battery is there, its EMF is 10 volt they mention. So symbolical representation of EMF is this one, its SI unit is volt, and internal resistance is 3 ohm. So internal resistance means small r here, it is 3 ohm, connected to a resistor if the current through the circuit is 0.5 ampere. How much amount of current is flowing through the circuit here? 0.5 ampere of current is flowing. What is the resistance of the resistor? Which thing I need to find out here? Resistance of the resistor first thing. And what is the terminal voltage of the battery if the circuit is closed? So which thing I need to find out here? Terminal potential difference. So look at the meaning of the question. So they mention one cell. That cell is connected to one resistance element. So I want to find out that resistance of this resistor. So EMF of the cell is 10 volt and this cell having certain kind of EMF. So remember that. So if that resistance I made nearby the cell, means so that you can take it as internal resistance. So that is present inside the cell. For my practical difficulties, so I am unable to draw inside the cell. So just I can take side that. So internal resistance is 3 ohm. Then what about the terminal potential difference I need to find out? Shall I use this formula? I is equal to E divided by R plus of R here. So look at here, which thing I need to find out? R value. So I value, E value and small r value already they given. So current value is 0.5 ampere, EMF value is 10, R plus of internal resistance value is 3 ohm. So R plus of 3, it is equal to 10 divided by 0.5. 0.5 is nothing but what? 1 by 2 here. So 1 by 2 means, so that is 20 here. R plus of 3 is equal to 20. R is equal to what? 20 minus of 3. R value is how much? 17 ohm. What is the resistance of that resistor here? So that is 17 ohm. Now terminal potential difference. So V is equal to, shall I use this formula? I minus of I into R. Sorry, E minus of I into R. So 10 volt, current is 0.5 and internal resistance is 3 ohm here. So 3 by 2 means 1.5. Terminal potential difference value is 8.5 volt here. So hope you understand. The next question. When a current drawn from a battery is 0.5 amp, its terminal potential difference is 20 volt. So on battery is there, from the battery, so 0.5 ampere of current is flowing here. So in this situation, what is the terminal potential difference of the battery here? So that is 20 volt. And when current drawn from it is 2 ampere, from the same battery 2 ampere of current is drawing here, terminal potential difference reduces to 16 volt. So if 0.5 ampere of current is flowing, means terminal potential difference is 20 volt. Now instead of 0.5, if 2 ampere of current will get flow, means so terminal potential difference reduces to 16 volt. Then they asked to find out EMF and internal resistance of the battery. Which thing I need to find out? EMF and internal resistance of the battery I need to find out here. So look at here, in order to find that one, so I will use that same formula. V is equal to E minus of I into R. This is for first case and this is for second case. For the first case, what is the terminal potential difference? 20. EMF value is yet to be determined, minus, so how much current is flowing here? 0.5 ampere of current is flowing. In that second case, same thing, V value is how much? 16 here. EMF value is to be find out. So how much amount of current is flowing here? 2 ampere of current is flowing here. So now I have to solve these two equations. So look at here. In order to solve this equation, here 0.5 R is there, so here 2 R is there, so it is impractical. So just I will simplify this equation. For this equation, if I multiply by 2, so it becomes 40, it becomes 2E. So 0.5 is nothing but 1 by 2, so 2 into 1 by 2, so that is R here. So this is equation 1. So now I am having equation 1 and 2, so now I will subtract these two equations. So 40 is equal to 2E minus of R, 16 is equal to E minus of 2R. So look at here, here 2 is there, here E term is there, here R term is there, here 2R term is there. So no terms is getting cancelled out. Again, for this equation I will multiply by 2. So 2 into 40. So that is 80 here. So 2E into E. So that is 4E into 2R. So if you subtract this equation, 80 minus of 16. So that is 64. 3E. These terms will getting cancelled out here. E is equal to 64 by 3. 3 ones are 3 twos are 21 point. So 3 here. So what is the answer here? So here that, so 64 by 3, so it is nearly about 22, or you can take that, so exact value. So 64 divided by 3, so 64 divided by 3 means so 21.3 here. So what is the answer here? So 21.3 here. Now look at here, what is that EMF value? 21.3 volt. So then I have to find out that internal resistance of the cell here. So again, that for example V is equal to E minus of I into R. So look at here, so just I will fill the value here. So EMF value is 20, sorry, terminal potential difference value is 20, EMF value is 21.3. Next, minus of current value, so that is 0.5 into, so resistance value is how much? Internal resistance value. So that internal resistance value only had to be determined here. Next, so look at here, 0.5 into R, I will take it into right side. So left side I will take 0.5 R is equal to 21.3 minus of 20. So that is 1.3 divided by 1 by 2. So 1.3 into 2. So that is 2.6 ohm. What is that internal resistance here? Internal resistance is 2.6 ohm here.